In this lesson, I'll discuss SSH, or Secure Shell. I'll discuss what SSH can do and how we practically keep it safe from attackers. SSH is turned on by default on most systems. We can check that it's running by typing in ps aux grep SSH. The SSH daemon here, located in user sbin sshd, is running. It's very easy for us to test if SSH is running on a remote host. It's so easy because typically SSH runs on port 22. We'll discuss how to secure it in a little bit. SSH has many security features built in. SSH is capable of shell access, file transfers, executing remote commands, port forwarding and tunneling, creating VPNs, forwarding X displays, that's our GUI, encrypted proxy browsing via the SOCKS protocol, and mounting remote directories. Typically, a system administrator is going to use SSH to copy files. This comes in the form of SCP. SCP works nearly the same way as SSH, but there's other things that we can do with SCP. We can actually transfer files and zip them up at the same time over SCP. I've done this with numerous systems, and it saves a lot of time in the long run if we're backing up systems. The command SSH looks like this: SSH username at hostname. Okay. We could also issue command after it if we want to. So we could say ls-l if we would like, without the square brackets. File copying via secure copy, or SCP, is as simple as typing SCP, the file name, user at host, colon, home, or wherever you want, wherever your files are located, home, user, file name here. Okay, this is based on Secure File Transfer Protocol, or SFTP, but it's not meant to replace RCP. Let's test this out. Look up my IP address by typing ipconfig. Here, my interface is 192.168.18.131. I'm going to go over to another distribution called 4linux. 4linux is a security distribution aimed at penetration testing. And I'll show you why here in a minute. So we're going to SSH greg at 192.168.18.131. It's also going to ask me the first time that I establish a connection what the fingerprint of the machine is. I'm going to type in yes. What this does is it keeps a list of known hosts. This way, if a server were ever compromised, or if I ever tried to connect to this IP address again, and the 256 SHA hash here doesn't match, when I connect to this again, it's going to deny the connection. So notice that I'm able to successfully SSH into the system. Okay, who am I? Who am I is a command that I run to see who I am. Let's look Okay, here is my home directory that I had created the other day. And when we SSH in, it's going to go into that folder. So SSH is a pretty commonly attacked port. And if you have port 22, which is the standard port for SSH open to the internet, you're going to get a lot of attacks. The way we need to solve this practically is by editing the port so that it doesn't answer on port 22. We need to change that to something that attackers are not going to try. Typically, attackers scan for well-known ports and move on if they don't find anything. So let's bring up an application called Nmap. And just for GUI purposes, I'm going to call up ZenMap, which is the GUI interface to Nmap. So I'm going to scan 192.168.18.131. Right now, I'm going to do a quick scan. A quick scan, denoted with -F, looks at very few ports. It looks at the commonly known ports. So if we scan really quick, we'll notice that it comes back with port 22 TCP is open and it's running SSH. It also gives me the MAC address, and obviously we know the IP address because that's what we typed in. So we need to change the SSH port. So we'll go back to CentOS, and we're actually needing to log out, so let's exit and close the connection. And here on my CentOS system, I'm actually going to change the port that SSH is running on. In order to do that, I'm going to type in vi etc ssh sshd_config. I'm going to scroll down to where it says port 22 and uncomment that line. I'm now going to change that port to 2237. I'm going to escape, write, and quit. Because this is CentOS 7 and SE Linux is turned on, I need to make sure that SE Linux knows that I'm making a port change. In order to do this, I'm going to type in semanage port-a-t ssh_port_t-p TCP, then the 2237. Okay, so what this does is instead of listening on port 22, it's now going to listen on port 2237. And I have to allow that with SE Linux. It's going to think about it a minute. And now I'm going to look at semanage and make sure that it actually took. So I'm going to type in semanage port-l, so listing the port, and I'm going to grep for SSH as the service. Okay, it looks like SSH port-t is listening on now both port 2237 and 22. This is okay as long as we change, which we did, the port that SSH was listening on. The only thing that we need to do now is restart the SSH service. In order to do this, I'm going to type in systemctl space restart space sshd dot service. And let's make sure that SSH is still running. PS aux grep SSH. Okay, it's running again. So let's try connecting back with Kali Linux. Okay, looks like now I can't SSH into it, but let's type in SSH-P2237 Greg at 192.168.18.131. Let's try to scan our port again and see if it comes back with anything. Okay, and port 22 is now closed. The next thing that I have to do is open the port in the firewall. We'll talk about firewalls in Linux in a couple lessons, but first let's open up the port. The new firewall within CentOS 7 in Red Hat versions is called Firewall D. So I'm going to type in firewall-cmd --zone equals public --add -port equals 2237/TCP. Now I'm going to go back and double check that I can't just see port 2237 open. This shows us that port 22 is open on the firewall, however, there's nothing listening on the port, which is okay in this case until we actually delete the rule out of the firewall. So I'm going to change this to an intent scan and see what it comes back with. This may take a minute. Notice that not even our intent scan, denoted with an A, actually finds anything. So port 2237, while it's a low numbered port, it's not low enough where attackers are going to continually scan it. So it's mainly hidden from attackers. This is called obfuscation, where we're hiding things out in plain sight. If you have SSH turned on port 22 on a public IP address, you probably notice that you're getting attacked quite a bit. If you change the port on SSH, you'll now see that you're able to hide your port and it's not going to get attacked. Let's just make sure that we can actually SSH in now to that port. So I'm going to type in SSH-P for port, and the port number is 2237 Greg at 192.168.18.131. And notice that I can get in now. Understanding that you can hide SSH in plain sight is critical to make sure that your attack surface is lowered. Changing port numbers will help you not allow attackers to keep on trying the same service over and over and over again on port 22. In addition to changing the port, there is another risk of SSH. SSH allows us to enter a password for a user. However, if SSH were ever compromised and an attacker were to change the binary of SSH, they would be able to turn SSH into what we call a honeypot and steal users' credentials. So it's important to also look at other technologies such as two-factor authentication for SSH. This can be done with public and private keys. This also allows us to streamline SSH between systems. So in conclusion, SSH allows us to access other systems, but there are some security vulnerabilities that we need to be aware of when we're implementing the service for users. Changing the port and looking at authentication will go a long way in securing SSH.